Math 1100 2023 exam. I'll mention again, it doesn't matter what course code you are doing. Math is math. For Onza, math is math. You do the same topics, the course code is just to differentiate your programs. Okay. So starting with this one, find the quotient and the remainder when px, which is negative x to the power 4, is divided by negative 2x to the power 2 plus x minus 3. You want to find the quotient and the remainder. When the divisor, the one which is going into another number, is not a linear function, the only thing you can do is long division. So we're going to use long division for this one. You always take the one going into the other to be inside the brackets here. So that will be negative x to the power 4. The one that you're using to divide is negative 2x to the power 2 plus x minus 3. First thing first, what you do, you only use the numbers of the highest power of x. So I'm only going to get negative 2x to the power 2. So negative 2x to the power 2 into negative x power 4, that is going to give us a positive, okay, 1 over 2 x power 2. Look at this. What you are doing is x to the power 4 divided by 2 x power 2. That is why it is giving us a 1 over 2 times the x squared, because the x squared down will go into the x to the power 4 on top. And then that number that is on top, then we are going to distribute with everything. We are going to multiply. So 1 over 2x squared multiplied by negative 2x squared, that will give us still negative x to the power 4. 1 over 2x squared multiplied by negative x, that will be negative 1 over 2 x to the power 3. 1 over 2x squared multiplied by negative 3, that will be negative 3 over 2 x squared. When you do this, just add numbers here to maintain the values. This is having power 3, so add 0 x power 3. That is power 2, so add 0 x power 2 so that you can be able to work with these well. And then now at this point, subtract. Negative x to the power 4 minus negative x power 4, that is going to be a 0. 0x to the power 3 minus negative half power 3 x power 3, that will be positive half x power 3. 0x squared minus negative 3 over 2x squared, that will be positive 3 over 2 x squared. At this point, and then get the negative 2x squared again, take it into the term with the highest power here. So negative 2x squared into 1 over 2x to the power 3. So what we are doing is 1 over 2 x power 3 divided by negative 2x squared, which is the same as multiplied by 1 over negative 2x squared. So here the x squared can cancel with the x cubed, so I'm just going to remain with 1x. And then if you multiply the number, so the answer will be negative 1 over 4x. Negative 1 over 4x. Negative 1 over 4x multiplied by negative 2x squared. That is going to give us 1 over 4 multiplied by 2 is going to be 1 over 2. X squared multiplied by x, that is going to be x cubed. Negative 1 over 4 times x, that is going to be positive 1 over 4. The x becomes squared. Negative 3 by negative 1 over 4x, that is going to be positive 1 over 4, and then with a 3x. At this point, just add another number here, 0 with an x, so that you just maintain the numbers with the powers. Subtract again. Half x cubed minus half x cubed, that is going to be 0. 3 over 2x squared minus 1 over 4x squared. What is going to be the answer there? So basically subtract 3 over 2 minus 1 over 4. So what you want to do here is Just make the bases the same. I'll multiply on top by 2, I'll multiply down also by 2. This is the easiest way to make all the bases the same. So what I'll do is 2 times 3 is 6. 6 minus 1 is actually a 5. So that is going to be 5 over, the denominator has got 4. And this is x squared. And then the next thing, 0x minus negative 1 over 4x, that is just going to be a negative 1 over 4. Oh, I actually didn't multiply this. Negative 1 over 4 times negative 3. That was supposed to give me negative 3 of... Okay, I should have written 3 on top and then 4 like that and then with an x. Okay. When I do that, the next thing that I want to do is take again the negative 2x squared into 5 over 4x squared. The m should be, what is here? The highest power should be smaller than the highest power here. So negative 2 into 5 over 4x squared. So that is going to be 5 over 4 divided by negative 2, which is the same as times 1 over negative 2. So the answer will be 5 over negative 8. So I'll write it on top here, negative 5 over 8. There's not going to be any letter x there. Why? Because the highest powers of x on top here and what we are using to divide were the same. And then the 5 over 8 multiplied with negative 2, that will give us still a positive 5 over 4 with x squared. Negative 5 over 8 multiplied by the negative x, that will be positive 5 over 8x. And then now the last one, negative 5 over 8 multiplied by negative 3, that is going to be positive 5 by 3 is 15 over 8. Okay, so let me ask here, are we all good? Before we proceed, we are good? People are not answering. Is it being lost or... Okay, so to maintain just the number, I'll add a 0 here so that we can subtract well. Negative 5 over 4x squared minus 5 over 4x squared, that is going to give us, so I'm going to be writing here the result. That will give us a 0. Negative 3 over 4x minus, this is a 5 over 8. Let me write here, negative 3 over 4x minus 5 over 8. I can make the bases again the same. I'll multiply on top by 2, also down by 2. Remember, this is the negative 3, so it will be negative 6 minus 5, which is a negative 11. And then the denominator is 8. Just attach an x there because there is x. And then 0 minus 15 over 8, that will just be negative 15 over 8. So for this question, the quotient is the answer. So the quotient is this number on top. This is going to be the remainder. Okay, just like that. After you are done this, just say therefore the quotient is, you write that number on top, the remainder is, you write that other number, which is the very last number or the last term actually that you are going to be able to find. Now let's look at part 2. By factorizing the equation, solve it. And the equation we have is x to the power 3 plus x minus 5x minus 2 is equal to 0. The question should be, how do we factorize something that has got a power 3? X to the power 3 plus x power 2 minus 5x minus 2 is equal to 0. You can use the try and error method. What I mostly do myself is I'll just say let x be equal to 1. Where there is x, I'll be putting 1. So put 1 here, and then put 1 here, and then put 1 here. So that will be 1 plus 1, which is 2. 2 minus 5 is, that's a negative 3 minus 2. It's not giving me 0. So positive 1 has refused to prove. So positive 1 is not a factor. Try negative 1. Put where there is x negative 1. Negative 1 to the power 3 is negative 1. Where there is x, again put negative 1. Negative 1 squared is a positive 1. So this is going to be positive 1. Then where there is x, put negative 1. That will be positive 5 minus 2. This will not give you 0. So that is also refused. Where there is x, try to put a 2 now. 2 to the power 3, that is 8. 2 squared, that's a 4. 5 times 2, that is a 10 minus 2. 8 plus 4 is a 12. Negative 10 minus 2 is a negative 12. So you see, this one has given us 0. So x is equal to 2 is a factor. If you do that, if you just find one factor, then you are good. Okay, x is equal to 2 is a factor. So I'll write that x is equal to 2. And then I'll write the coefficients of this expression. The number in front of x to the power 3 is a 1. The number in front of x power 2 is a 1. In front of 5 is a negative 5. In front of, and the constant negative 2. Make sure that the powers are decreasing. In case we had something like x to the power 3 plus x minus 4. X power 2 is missing here. What we would have done is we write as x power 3 plus 0 x power 2 plus x minus 4. The powers should be reducing. Otherwise, you'll not be able to answer this one. So next thing is just put a 0 here, down here, and then add. Okay, add 1 plus 0 is 1. This one multiply with this 2, that will give you a 2. 1 plus 2 is a 3. This 3 multiplied by 2, that will be 6. Negative 5 plus 6 is a negative 1. Okay, and then is that a negative 1 or positive 1? Positive 1 times 2 is a 2. So the remainder should always give you 0. The last number that you find here is a 0, is the remainder. And it should always give you 0 if 2 is a factor. So that proves that 2 is a factor. So the meaning of this is that this expression this expression is actually this term that we wrote here. I can take to the other side, it becomes a factor as x minus 2. And then this expression here, the first term always add power 2. And then the second term just add x. The third term you don't add anything. So that will be 1x power 2 plus 3x plus 1. And this is going to be equal to 0. And then you can solve this. This means that x minus 2 is equal to 0, or x squared plus 3x plus 1 is equal to 0. And this means that x is equal to 2. For this one, I don't think we can use factorization. You can use the quadratic formula. But before you even use the quadratic formula, try to find out if it has got roots by finding the discriminant d. Square root of b squared minus 4ac. b is 3. 3 squared minus 4ac. So that is giving us a 9 minus 4, which is it a 5? Okay, since the number is positive there, that means that there is a discriminant, so we can actually solve this one. So x is going to be equal to negative b, and b here is 3, plus or minus the discriminant, which is the square root of 5, divided by 2a, is 2 times 1, meaning that x therefore is going to be equal to negative 3 plus square root of 5 over 2, or x is going to be equal to negative 3 minus square root of 5 over 2. So these are going to be the solutions to this one. I'll answer, I'll ask again. If you have got any question at any point, be free to ask. Given that n is a member of natural numbers, solve the equation n plus 2 Okay, just a moment. So we have been told that n is a member of natural numbers, and you want to solve the equation n plus 2 factorial. It is n plus 2 factorial is equal to 12n factorial. We need to know the meaning of a factorial. Very, very important. If you have got 8 factorial, it means multiply 8 with numbers below it. So starting with 8 itself, remove a 1 from 8 to give you 7. Remove a 1 from 7 gives you a 6. So that is the meaning of a factorial. So n plus 2 factorial means n plus 2. Remove a 1 from n plus 2, it will give you n plus 1. Remove a 1 from n plus 1, it will give you n. I can end at n. Okay? So just like this one, I would have written 5 times 4 times 3 times 2 times 1. But if I want, I can actually say 8 factorial is the same as 8 times 7 times 6 factorial, because from 6 we are multiplying it with all the numbers below it. So n plus 2 factorial is the same as n plus 2, n plus 1, and then n factorial. And I've strategically ended at n factorial because I've got n factorial this side, 12n factorial. The n factorial can cancel with the n factorial. So what I'm going to do is I'm going to expand here, n multiplied by n, that is n squared, n multiplied by 1, that is n, 2 times n, that is 2n, 2 times 1, that is a 2, and that is going to be equal to a 12. So this will be n squared, n plus 2, that is going to be 3n. Take 12 this side, 2 minus 12, that will be a negative 10, and that is going to be a 0. Look for factors. The product is 10, the sum is 3. If we say 5 and 2, okay, we use negative 2 and positive 5. That is going to prove 5 minus 2 is a 3, 5 times negative 2 is a 10. So this is actually n positive 5, and then n negative 2 is equal to 0, meaning that n is equal to negative 5 or n is equal to positive 2. Now we don't have a factorial for this negative number like that. It will continue going and going like that. So the answer is going to be n is equal to 2. Okay. We are not done with the question here. And then in the expression 2x minus 1 over 2x squared to the power 12, find the coefficient of the term that has got x to the power 3. And this question, you see it in different forms. Make sure that you just understand what's happening, all right? So you want a term that has got x power 3, but you can't expand this one writing all the terms because it will be very hard. So what do you want to do? You know that when you have been given a plus b to the power n, using the binomial theorem, if you are finding the, let's say, the rth term, the rth term is given by, you are going to get the same power. Okay, if this is r, then here you are going to put r minus 1. In other words, if that is 5 here, you are going to put 4. If that is 6, you are going to put here 5. If that is 20, you are going to put 19 here. And then you write the first term, you subtract the n with the r minus 1, and then now get b. Okay, and then whatsoever is down here, that is what you write as a power r minus 1. So that is how you want to work with this one. 2x minus 1 over 2x squared, and then this is raised to the power 12. So this should be, remember, I want to find a term that has got x power 3. So your aim is, when you're using the binomial expansion, remember, always supposed to have 12. I don't know the number that is supposed to be here, right? I don't know that number. But then, if whatsoever that number is, the 2x here, if I get it, the 2x, which is the first term in the brackets, I'm supposed to subtract this to 12 minus x minus this n. And then I'm supposed to get the number in the brackets here, right? Which is negative 1 over 2x squared. So whatever is down here, which is the n, I'm supposed to write it there. Let me expand. This is going to give us 12 combination n. We are going to have 2 to the power 12 minus n, and then also the x to the power 12 minus n. And this, okay, and then in the brackets negative 1 to the power n, so ever the number there anyway, and then also what is in the denominator 2 to the power n, and then x squared also will be raised to the power n, so it will become x to the power 2n. But your aim is, if you get this, which is x to the power 12 minus n, you divide it by the x in the denominator to the power 2n. It should give you a term that has got power 3. You know, according to the rules of indices, when you have got same bases dividing, subtract the powers. So this is x to the power 12 minus n, actually minus 2n, because that is in the denominator. And that will be equal to x to the power 3. I've seen a hand. Is that a question? Mm. Yes, it's the same thing. So when you are finding the term independent of x, you don't equate to. So here I'm just trying to find the value that I need to put here, such that the term that I'm going to find is going to involve x to the power 3. But for the term independent of x, what would have done is would have just gotten these two guys and equated them to find the value of the power. Is that okay? Okay. So now at this point, we are going to equate the powers. So 12 minus the 3n should be equal to 3. I'll take 3 the other side, so it becomes 12 minus 3, which is, if I take 3 the other side, what are we going to get there? Okay, did I even do the right subtraction? Okay. If I take 3 the other side, it's supposed to give me, what number is that? It's a 9, isn't it? And then this negative 3n here, I'll take it the other side of the equation, which is 3n, meaning that n should be equal to 3. This wasn't necessary for me to do. I could have easily identified that n is equal to 3. But then, how do you identify for you that n is equal to 3? So this is how you can do it. Now, identifying that n is equal to 3 will not do anything good to you, because you've still not found the coefficient. That 3 will just help you to be able to substitute and find your answer. Okay. So now we can go in our expression. So it means that when we write our expression, the number that should be down is 3. This means that the term that is in x power 3 is actually the fourth term. So we are now going to say fourth term is equal to 12 combination 3. Remember, the number that you write here is always 1 down from the term. And then write the 2x, subtract 12 minus 3, that is going to be power 9. And then write the next term in the bracket, which is negative 1 over 2x squared. So whatever is down here, that becomes its power, which is power 3. Okay, like that. This is going to give us 12 combination. 3 means 12 factorial divided by, subtract 12 minus 3, 9 factorial. And then whatsoever the same 3 you are subtracting, write it 3 factorial. And then you have got 2x to the power 9. So 2x to the power 9 means 2 to the power 9, and then multiplied by x to the power 9. Negative 1, negative 1 to the power 3, that would be just negative 1. 2, and then you have got 2 to the power 3. X squared to the power 3, that would be x to the power 6. This x to the power 6 can go into x to the power 9, and then the answer will be x to the power 3. And then this 2 to the power 3 can go into 2 to the power 2 to the power 9, and then the answer will be 2 to the power 6. So this becomes the 12 factorial. I can write it as 12 times 11 times 10 times 9. At 9, I'll end and put a factorial. Strategically, because in the denominator, there is also a 9 factorial. Then 3 factorial is actually 3 times 2 times 1, which is a 6. And then remember, we have got times 2 to the power 6, and then times x to the power 3. 9 factorial cancel the 9 factorial. This 6 can go into 12, and the answer will be 2. So here 2 times 10, 2 times 11 is a 22. 22 times 10 is a 220. Remember, you have got times 2 to the power 6 and then x to the power 3. So this one, just simplify. 2 to the power 6 multiply 2 times 2 times 2 times 6 times. The answer you get to multiply by 220, like that. But at this point, even if you can simplify further, even at this point, at least of the 4 marks, I should give you 3. Unless someone who is marking your paper depends on the marking scheme, and then they also don't know math. Expand 1 over 1 plus x over 2 in ascending powers of x, including the term involving x to the power 3. Okay, we want to expand this one. Now, the way it has been given, I can't expand it, so I can take it on top, alright? So if I take it on top, it becomes 1 plus x over 2. Remember, immediately you take something on top, the power becomes negative. Okay, and then from here, we'll use the same binomial expansion. The same binomial expansion. Now, on the binomial that we have talked about, hope you have not forgotten the formula. What we said is, firstly, when you're expanding, the first term, you always get a number given in the bracket, raise it to the power, whatever the power here. So it will be 1 to the power negative 1. But 1 to the power anything, the answer is 1 itself. And then plus, now get the same high, the power, which is negative 1. Now write a 1 here. Get the same 1, okay? Subtract these two terms, negative 1 minus 1, that will be negative 2. It becomes the power. And then get the second term given, which is x over 2. The number that is in the denominator here, that's not actually the denominator, but the number that is down will become its power. So that will be power 1. And then plus, write again the power negative 1, but put a 2 here. Get again the first term in the brackets here, and that is a 1 in this case. Subtract these two, negative 1 minus 2 is negative 3. Get the second term, which is x over 2, and then raise it to the power 2, that number here. The last term you need to write now, write negative 1, put a 3 here, and then write the first term in the bracket, which is 1. Negative 1 minus 3, that is negative 4. And then write x over 2. So whatever the number in the down here, that becomes the power. This will continue to go, but then the question is saying including the term in x to the power 3. So we don't need to go beyond that. Are we okay here? Are we good? I want people to understand this. Trust me, this barely do they miss the questions on binomials. Okay. So hope people understanding and are not just keeping quiet. All right, we can proceed from here. So this is going to be 1. It's complicated, huh? I understand. Especially if you didn't understand it in class and then we are revising for an exam in a few days. But what I'll do, for you guys who have access to the recorded videos, in the same playlist, I've put almost all the topics. Just go binomial expansions. At least try to follow it. Unless if you've made up your mind, whatsoever the question that you have binomial expansions, I will not answer it. In that case, well and good. Okay. So negative 1 combination 1 means negative 1 factorial divided by the same negative 1 minus 1. that would be negative 2, put a factorial. So ever the number which is down here, which is a 1, also put a factorial. Negative 1 factorial means negative 1 multiplied by the number less, 1 less than it. So negative 1 minus 1 is negative 2. That's the number 1 less than it. So put a factorial on negative 2 because you also have negative 2 factorial down. This will cancel with this, so the answer will just be a negative 1. So this is a negative 1. 1 to the power negative 2 is just 1. So negative 1 times x over 2, that will be negative x over 2. Go to the next term, negative 1 combination 2. So the only difference is this will be negative 1 factorial divided by negative 1 minus 2, that will be negative 3 factorial. And then the same 2 which we are subtracting becomes 2 factorial. So negative 1 factorial means negative 1 times negative 2 times negative 3. At negative 3, I can end and put a factorial because in the denominator I also have a negative 3 factorial. And then times, we have got 2 factorial, which is 2 times 1, which is basically a 2. The negative 3 factorial down will cancel the negative 3 factorial on top. These 2 can go into a 2 here. So I've got negative 1 times x, which is a positive x. Okay, that is a, sorry, negative, this is a negative 1, just I'm seeing x here. This was a times, it's not x. So that is just a negative 1 there. Negative 1 times z. Remember we had cancelled. Oh, this was actually, did this one have x? No, this wasn't x. So it was negative 2. We cancelled it with a 2 down, so it remained as a negative 1. Negative 1 times negative 1 is a positive 1. So that positive 1, so this is positive 1, we're multiplying by 1 to the power negative 3, which is also 1, and then times x over 2 squared. So this is 1 times x squared over 4, which is basically x squared over 4. The next one is negative 1 combination 3. So the only difference with a combination where you have got a 3 is you are going to say negative 1 factorial, then subtract negative 1 minus 3, that will give you a negative 4. Put a factorial. The same 3 in the denominator, also put a factorial there. So negative 1 factorial is meaning negative 1 times negative 2 times negative 3 times negative 4. At negative 4, I put a factorial because I've got a negative 4 factorial down. And then 3 factorial down is 3 times 2 times 1, which is basically a 6. Negative 4 factorial cancels negative 4 factorial. Negative 1 times negative 2 times negative 3 is negative 6. That negative 6 can cancel with this 6, so the answer will just be a negative 1. That negative 1 times 1 to the power negative 4, which is just a 1. X to the power 3 is x power 3, and then 2 to the power 3 is 8. So that will be negative x to the power 3 over 8. Plus, the terms will continue going, but our interest is only ending at the power x power 3. So that is the expansion for this one. Part 2 is saying state the interval of which the expansion in 1 is valid. Every time you are talking about interval for which the expansion is valid, you always get what is here, which has got an x here. So the absolute value of that number, x over 2, should always be smaller than the number that is here, okay, than 1. We know absolute value means it can either be positive or negative, right? So at this point, I can actually factorize out. If you can check in the brackets, we have got a 1 over 2, even if you can't see. And then I will say x less than 1. That 1 over 2, absolute value of 1 over 2 is 1 over 2 itself. So it will be 1 over 2, and then you still remain with absolute value of x in the brackets, and that will be less than 1. To do away with that 1 over 2, multiply everything by 2. So absolute value of x is going to be less than a 2. And the meaning of absolute value of x being less than a 2, it means that it is a number between, you can, if you want, just write it like this if you can go further, but this means that x can either be positive or negative. So you can write it as negative 2 is less than x and x is less than 2. In other words, absolute value of x is less than 2 means we're talking about numbers from negative 2 to positive 2. So this function won't be valid for this interval. Okay, so that is it. And then we have got this question here. Differentiate, and you want to differentiate from the first principle. So the first principle is f prime of x, which is the derivative. You can also write dy over dx is equal to limit as h approaches 0 of f of x plus h minus f of x divided by h. So if you cannot remember this, it means you'll not be able to remember or to answer it correctly. So this becomes limit as h approaches 0. In this function, where there is x, we're going to put x plus h. So that becomes 1 divided by square root of x plus h, and then plus 1. And then remember it is minus f of x, meaning write f of x itself, write the function the same way it has been given, that is f of x. So minus 1 divided by square root of x plus 1. Remember everything is supposed to be over h. At this point, merge the numerator as a single fraction. What you do is get the number on top of the first fraction, multiply with the number down the second fraction. That gives you square root of x plus 1. Multiply the negative 1 on top of the second fraction with the number down the first fraction. That will be negative square root of x plus h, then minus a 1. And then divide. Multiply the two denominators. So that is the square root of x plus h plus 1. You are also multiplying it by square root of x plus 1. Please put this in brackets. Remember in the denominator we already also had h. So I'll again put h there. This number can cancel with this number here. Okay, they've cancelled. So what will remain with, let me just, instead of me rewriting again, let me just remove this. Remember I've got square root of x here. So I can write here square root of x. At this point, you want to make sure that you substitute where there is h with 0. But if you substitute where there is h with 0, there's going to be 0 in the denominator, and you don't want a denominator with a 0. So what you do is now conjugate, multiply the top and the bottom by the conjugate of the top. So multiply by square root of x, change the sign, plus square root of x plus 2. Also down, multiply by square root of x plus square root of x plus 2. If I multiply the bottom by this term, what we just see is this same term. Now if I multiply the top, when you multiply a number by its conjugate, just get the first number, you square it. Always subtract, write the second number, also you square it. So I'll not even write this. So all I'm going to do is I'm going to get the x, I square it, so the root will go. You can see it has gone. I'll get the square root of x plus 2, I square it, so the root also go. But remember this was in a root, so this will actually be in brackets like that. I wonder why I wrote this as a 2. This was supposed to be h, not a 2. If I remove the brackets there, the x will cancel with the negative x here, and this negative will multiply with the h inside, it becomes negative h. So the only thing that remains on top is a negative h. This h can now cancel with the negative h on top, so we have just a negative 1 that has remained on top. It is at this point now that you substitute where there is h with a negative 1. So that will give you negative 1 divided by, in the brackets here where there is h, I'll substitute a 0. So it will just be square root of x plus a 1. Okay. And then in the bracket, next brackets, we only have square root of x plus a 1. In the next, we have got square root of x plus, where there is again, this was all supposed to be h not 2. Where there is h again, put 0, so that will just be square root of x. Just simplify this. So this is negative 1. Square root of x plus 1 times square root of x plus 1, that is going to be square root of x plus 1 squared. Square root of x plus square root of x, that is 2 square root of x. Just to write it in a good way, this is actually negative 1 on top. In the geometry I've got a 2, okay, and then I write square root of x, and then I write square root of x plus 1 squared. So that is it, right? Mostly for this one, if you lack accuracy, you are more likely to get it wrong or lose some marks. Make sure you are as accurate as possible. Don't write things together, pinching them together. If there's no space, move to the next page and make sure you are clear as possible, because it will prevent you from making any possible mistake which can make you lose marks. That is a problem, because a lot, when they're answering, they want to fit all their work at one point even if there's no space. No one will be forced to be seeing what they can't see. They have got a lot of things to mark, and so that is why others end up failing, because of their work not being clear. Now let's go on with the second. Want to find the derivative of what you've been given. So we'll find dy over dx. If you can look at this term, there are a lot of ways in which we can do it. If I wanted, I can actually even make it as a product and then use the product rule. But using the same way it has been given, the first thing is get the power, which is 3. Write the term the same way it is, x plus 2 divided by x minus 3. And then reduce the power by 1. So that becomes power 2. And then multiply. Now differentiate what is inside. But as you are differentiating what is inside, you are going to use the quotient rule. Maintain what is down, x minus 3. Differentiate what is on top. That is going to give you only a 1. And then minus, maintain what is on top, which is x plus 2. Differentiate what is down, that will give you a 1. And then over, write what is down, you square it. So that will be x minus 3 squared. So this is 3 x plus 2 over x minus 3 squared multiplied by. So on top I've got x minus 3. Distribute this negative, that will be negative x minus 2. This x can cancel with that x, so we're just going to remain with a negative 5. Down, we are going to have x minus 3 with a squared like that. Another way I can write this, I can multiply this 3 times negative 5, that is actually negative 15. And then I've got the x plus 2 over x minus 3 squared, I can write as x plus 2 squared. And then the x minus 3, I can also write it as x minus 3 also squared. But remember, we also have another x minus 3 squared. So this gives you negative 15 x plus 2 squared over x minus 3. This is going to be raised to the power 4. Okay, like that. Let's look at this one. Use an appropriate substitution to evaluate the following integral. At least the people who wrote this exam were lucky. They've even told you use substitution. They've even told you the formula, because integration has got a lot of formulas you're supposed to use. You're supposed to decide for yourself which one to use, but this one is direct. All right, so how do you answer it then? To be able to answer it, mostly the part that has got the highest power when you're using substitution, you are going to substitute it with x. So in this case, we are going to say let u be equal to, what is having the highest power is 3x to the power 4 minus 8. Okay, you are getting the entire term. You don't get the brackets, don't get the root, don't get anything. Just get what is inside. The dx there, don't worry about it. At this point now, what you want to do is to differentiate this term. Because we have got u, then it means that we're going to find the derivative of u with respect to x. That is du over dx. So what I'll do here, I'll just write du. I'll not write dx. 3x to the power 4, if you differentiate it, to give us 12x to the power 3. Negative x, if you differentiate it, negative 8, if you differentiate it, to give you 1. So instead of me writing du over dx, that dx I'll multiply and it comes here. Okay, and then at this point, what I want to do is I want to make dx update the formula, so it becomes du divided by 12x to the power 3. I'll go back now to the integral, so it becomes integral of 2x to the power 3 and then square root. Where there was the 3x to the power 4 minus 8, where there was this term, I'm putting u. Where there was dx, dx is actually du divided by 12x to the power 3. The x power 3 will cancel with x power 3. These two can go into a 12, that will be 6 times. So this is the same as we have got 1 over 6. There is a 1 that has remained here, 6 in the denominator. That constant, we can bring it outside the integral, so that will be 1 over 6. Then we have got integral of x, square root of x du. I mean square root of u du. Square root of u is the same as u to the power 1 over 2. And then we have got du. When you are integrating a function, just add the 1 to the power, so that becomes 1 half plus 1 is 3 over 2. The same power, divide by it, 3 over 2. And then just add a constant c. These two can go into 6, and that will give you a 3. And then you have got 3 times 3, which is a 9, meaning that our answer is going to be u to the power 3 over 2. Now u to the power 3 over 2 means square root of u. Okay, the number that is down is the nth root. The number that is on top becomes the power there. So this is square root of u to the power 3. Now square root of u to the power 3 means square root of u times the square root of u times square root of u. Square root of u times square root of u is actually u. So this is u square root of u. So u to the power 3 over 2 is u square root of u. But remember, we have got a 9 in the denominator. So this is going to be u square root of u divided by 9 plus c. Now we go back. What is our u? Our u, remember, was 3x to the power 4 minus 8. And then we have got the square root of 3x to the power 4 minus 8. Everything supposed to divide it by 9 in the denominator, and then plus a constant c. So that is the integral of this expression. Integration is not too easy. So what I did is that I did all the integrations: integration by parts, integration by partial fractions, by use substitution, by change of variable, and also there are some other special substitutions. In the playlist, immediately you register, the videos, just I think just below the past papers, contains all integrals. Just try to pass through. I told the guys I was teaching last year that make sure you know integrals. You will not say, no, I have an option, I'll choose. How about if it comes on every question? And well, it came like that. Calculus was everywhere. Okay. Use partial fraction decomposition to evaluate the following integral. You've seen again, here you are just using partial fractions. So you need really to know integrals. If you have access to the videos and then you have not watched those videos on integrals, they are very easy to understand. Just try to go through them. So here first we'll break this into partial fractions. X plus 1 divided by x minus 1, x minus 2, x minus 3. So this is going to be equal to, look at the denominators, you have got x minus 1 plus, you have got x minus 2 plus, you have got x minus 3. As long as the denominators are linear, just add a on top, add b, add c. You can use any letters that you want. The next thing is, what we want to do is merge this as a single fraction. Just multiply the denominator. So we're going to have x minus 1, x minus 2, x minus 3. When you get x minus 1, you take into this denominator, we're going to remain with this term this side. This term you multiply with the a. So we're going to have a, x minus 2, x minus 3. If you get x minus 2 taking the denominator, only this term will not be there. So remain with x minus 1 and x minus 3. And that you multiply by b. So we're going to have b, x minus 1, x minus 3. And then if you get what is down c, x minus 3, taking the denominator, you're going to remain with x minus 1, x minus 2. That you multiply by c. That will be c, x minus 1, x minus 2. Okay, like that. At this point, what you want to say, as you can see, for these two ends of these fractions, The denominators are the same. Since the denominators are the same, just equate the numerators. So that will be x squared plus 1 is equal to a x minus 2 x minus 3 plus b x minus 1 x minus 3 plus c x minus 1. What is that? X minus, didn't I miss it somewhere here? This is x minus 3. For b, what was it supposed to be? Okay, this is supposed to be x minus 2, not x minus 3. Okay. When you reach here, you want to look for, you want to start canceling out some terms. And how do you do that? Try to find out a value of x that you can substitute so that you can eliminate some letters. You want something that will give you a 0. For example, for the first one, if I want to eliminate a, I've got x minus 2, right? I can substitute where there's x with a 2. So I'll say let x be equal to 2. I'll put at every point where there's x with a 2. So 2 to the power 2 plus 1, that is going to be a 5. And that will be equal to, let's come here. If I put 2 here, 2 minus 2 is 0. 0 times everything here, everything will be 0. So meaning that a has disappeared. I'll go to b, where there's x, I'll put 2. 2 minus 1 is 1. 2 minus 3 is a negative 1. Negative 1 times b, that is a negative b. I'll again go here. Immediately I put 2 here, 2 minus 2 is a 0. So meaning that also c has cancelled. So meaning that b is actually equal to negative 5. Okay. And then we'll go to a. Let's go to b. Where there's x, let me put 1. So this will become 1 squared plus 1, that is going to be a 2. If I substitute here, 1 minus 2 is a negative 1. 1 minus 2 is a negative 2. Negative 1 times negative 2 is a positive 2 times a, that is going to be 2a. And then if I put a 1 here, everything will be 0. If I come and put 1 here, everything will be 0. So meaning that only a has remained. And a here means that it is equal to 1. And then I'll put where there is x with 3. Alright. 3 squared plus 1, that is going to give us a 10. And that will be equal to, if I put 3 here, 3 minus 3 is 0. If I put 3 here, 3 minus 3 is 0. So only c will remain. If I put here 3 minus 1 is a 2. 3 minus 2 is a 1. So 2 times c times 1, that will be 2c. Meaning that c is equal to 5. So what we have done is, we have already broken this into partial fraction. So in that expression which I had written earlier, that is where you're just supposed to put. So then we write integral of x squared plus 1 divided by x minus 1, x minus 2, x minus 3 dx is actually equal to the integral. Okay, where there was a, we are putting 1. Remember, it was 1 over a over x minus 1. Where there was b, we are putting negative 5. So that will be negative 5 over x minus 2. Where there was c, we are putting 5. So that is 5 over x minus 3. Everything in brackets, put the dx at the end. If you have got an integral as this one, you can split the integral. So we're going to have integral of 1 divided by x minus 1, add dx, and then plus integral, you have got negative 5 over x minus 2, add dx, plus integral of 5 divided by x minus 3, add dx. Whenever you have got the integral of 1 over x dx, this is always natural log of whatsoever that is in the denominator, that is x. Okay, that is the integral. So the integral of 1 divided by x minus 1 is the natural log of the absolute value of x minus 1, that term in the denominator. Now for this guy here, I'll first remove the negative 5 from the top there. I'll factorize out the negative 5. Okay, so if I factorize out the negative 5, it will be here. And then we remain with 1 over x minus 2. That 1 over x minus 2, now we find this integral, and then it will be natural log of x minus 2. And then plus, we have got the integral of 5 over x minus 3. Factorize out a 5, remain with 1 over x minus 3. So that will be just natural log of x minus 3. At the end, just add a constant c. So that is how you find the integral for such an expression. Question C. Sketch the graph of the function f of x is absolute value of cosine of theta. To start with, we want to sketch between 0 and 2 pi. A cosine graph will alternate between 1 and -1. To go the way up to 2 pi, the middle of 2 pi is a pi, the middle of pi is pi over 2, the middle between pi over 2 and 2 pi is a 3 pi over 2. Cosine graph always starts at positive 1. As long as there is a positive number in front, it will start at positive 1. And when it reaches 3 skis, it will be at positive 1 still. The middle between 0 and 2 pi, that is where it's going to reach the minimum. And then these middles, that is where it will cut the x-axis. So the function is supposed to be going down like this. It was supposed to go down like that, and then come down like that, and then go back like that. But because it's absolute value means it can't be down. So instead of it going to -1 at pi, it will actually go to positive 1. So it turns back and goes like that. So this is going to be the sketch of this function. Okay. And then we want to solve the equation tan theta, open brackets, tan theta plus 1 is equal to 0. When something is equal to 0, that is very easy. Simply say tan theta is equal to 0 or tan theta plus 1 is equal to 0. If this wasn't 0, if it was any number, you should have expanded to taken that number also the other side, and then you start factorizing again. So tan theta is equal to 0. So the question is, what numbers will give you 0 when you're talking about a tangent graph? Don't you remember, you don't use a calculator, meaning that you need to know of some special angles. So just know a bit of these graph sketches. Can know the important values. I've got 90, 180, 270, and 360. So you need to know at least a tangent graph, how it is going to move. So one of these values are going to be asymptotes. 90 is an asymptote. That means we don't touch it. 270 is also an asymptote. We don't touch it. So this graph will be trying to go up. Just a moment. Okay. So this graph will be trying to go up. It's going up like that. It will not be able to touch 90. This side it will continue and go to -90 like that. Then between 90 and 270 to be going up like this, it will actually come and pass here and then continue to go up. And then here it will also continue going like this, and then like that it will continue going like that. This is a tangent graph, meaning that the only two values where tan will be 0 is at 180 and at 360. At 90 and 270 the graph is undefined. So to find the theta, we're supposed to say tan inverse of 0, and tan inverse of 0 is actually this one. We are giving the answers in radians. It's 180, 180 is pi, and 360, which is 2 pi. Okay, and then we come to this one, which is tan theta plus 1 is equal to 0. What we just want to do here is just to take 1, the other side will remain with tan theta. So that gives us tan theta is equal to -1. I don't want to be dealing with negative numbers. Change where there is theta with a positive. That's what you do easily with negative numbers. Let me put alpha. So tan alpha is equal to +1. I want to find alpha. So alpha is going to be tan inverse of 1. Now tan inverse of 1 should be like a 45. You can these are special angles. If you have got 45, this is 1, this is 1, this is square root of 2. The angles here is 45. Tan is opposite over adjacent. Opposite is 1, adjacent is 1. So tan 45 is 1, meaning that tan inverse of 1 is 45. And 45, we convert it to radians, multiply by pi over 180. How many 45s are in 180? 4 of them. So this is pi over 4. So meaning that alpha here is pi over 4. Our aim is not to find alpha, our aim is to find theta. So go on the quadrant system. All students take copy. Where is tan in negative? It is negative in the second quadrant and also in the fourth quadrant. Therefore, theta, when you are finding angles in the second quadrant, is always 180, which is 2 pi minus the first quadrant angle, which is pi over 4. And this is going to be 8 pi minus pi, which is 7 pi over 4. The other angle, when you are finding fourth quadrant angles, you always from 360. Oh, sorry, this was supposed to, so this is the one actually in the fourth quadrant. 2 pi is 360. In the second quadrant, you subtract from 180, which is pi. So that would be pi minus the same pi over 4 which you had found. And this is going to be 3 pi over 4. Therefore, the solution set to this question, the first angle, which one is the smallest here? We are going to have 3 pi over 4 as the first angle. The other angle here is pi. The other angle, I'm writing them in increasing order, is 7 pi over 4. Then the last one is 2 pi. So these are the solutions to this one. Okay, like that. Find dy over dx given that x squared minus xy plus y squared is equal to 3. This question, if you saw in the previous class, should have been on question 3. I don't know if they didn't want people to escape from it. They give it at question 3 somewhere there and then they've brought it here also. So to be able to differentiate this, just add d over dx. The derivative of x squared is 2x. And then in negative, we want to differentiate now xy. When you're differentiating a product, first maintain one, you differentiate the other. Let me maintain y, I differentiate x, I'll get 1. Plus maintain x, differentiate y, you get 1. Every time you differentiate y, add dy over dx. Look, I factorize out this negative, very important. And then I'll differentiate again to y squared, that will give us 2y. Every time you differentiate y, add dy over dx. And this is going to be equal to 0. So this is going to be 2x minus y minus x dy over dx, and then plus 2y dy over dx, that will be equal to 0. Factorize out dy over dx on the part with dy over dx, so on this one. So I'll factorize out dy over dx, and that we are going to have 2y, and then we are going to remain with also negative x. And this will be equal to, take these other terms the other side, so the y will become positive, the 2x will become negative. To do away with the 2y minus x, divide both sides by 2y minus x. So this will cancel this term here. So this is the derivative. dy over dx will be y minus 2x over 2y minus x. If you are just watching, you don't want to ask, it's very bad. Okay. So we want to find the integral of 4x to the power 3 natural log of x. Anyone? What method do you think we are going to be able to use to integrate this one? Anyone with ideas on integration? Okay. So we can use integration by parts when you see a product of two functions. But by parts is not that easy. what I'll use is a very simple method which is known as a tabular method. For a tabular method, you just put signs, you put derivative, and then you put integral. You want to make sure that you put something derivative as something that you can easily differentiate. So between 4x to the power 3 and natural log of x, which one is easy to integrate? That should be the question. Actually, what I can do is this guy, I can factorize out 4 because it's a constant, and then we remain with integral between e and 1 of x to the power 3 natural log of x dx. Question should be which one is easy to differentiate between natural log and x to the power 3, and which one is easy to integrate between natural log and x to the power 3. Both of them are easy to differentiate, but to integrate, you can't integrate natural log of x. You again require this same method. So because it is not easy to integrate natural log of x, I'll put natural log of x under derivative, and then the x to the power 3 under the integral. If you differentiate natural log of x, always get the same number here, natural log of that number or term, the x, differentiate x, you get 1. Divide by the same thing that you differentiated, which is x. That is why we say that the integral of 1 over x is always natural log of whatever is in the denominator, because they are just opposites of each other. And then come here, integrate x to the power 4, x power 3, add the 1 power 4, the same power comes down. It's enough. I'll just end here. So put a positive here, put a negative here. So what you want to do is now you are multiplying the terms in this way. So positive times natural log of x times x to the power 4 over x, meaning that this 4 natural integral of between e and 1 of x to the power 3 natural log of x dx is going to be equal to a right 4. So if I multiply positive times natural log of x times x to the power 4 over 4, that will give us x to the power 4 over 4 natural log of x. And then we're supposed to again multiply another diagonal, but we don't have another diagonal. So in this case, just multiply in this way. Every time you multiply horizontal, so negative times 1 over x times x to the power 4 over 4, the answer will be negative x to the power 3 over 4. Every time you multiply in the horizontal, always add integral. So that will be negative integral of x to the power 3 over 4. Every time you add the integral, don't forget with respect to x dx. So before, I've got x to the power 4 over 4 minus, I'll remove the constant outside the integral. So I've got 1 over 4 here. So I'll remove that 1 over 4. Then we remain with integral of x to the power 3 dx. And this will give us 4. We are going to have x to the power 4 over 4 minus 1 over 4. The integral of x to the power 3 is actually just add the 1 to the power, that will be x to the power 4 over the same 4. And then just add the constant c. So you are done. What you have to do is just simplify. Distribute the 4 times x to the power 4 over 4. That is just going to be x to the power 4. Okay. And then 4 mod this 4 also cancel with this 4. So I'm going to have negative 1 times x to the power 4 over 4. That will be negative x to the power 4 over. Oh, I actually forgot something here. There was actually a natural log of x. Even here, natural log of x. So don't forget that. That would have been a very big mistake. And it seems people are not following because you can't tell me that I've left out. So that would be negative x to the power 4 over 4 and then plus a constant c. So this is the integral. Write down the expression log in base b of 12 minus 1 over 2 log in base b of 9 as a single logarithm. This is also log in base b of 12. The 12 in front can go as a power to 9. So it becomes 9 to the power half. And 9 to the power half is a 3, meaning that this is log in base b of 3. And this will give us log in base b. When you're subtracting, divide the terms 12 over 3, which is basically log in base b of a 4. Prove the identity. And this identity was very complex. Huh? Which side do you think is easier to prove? Is it the left or the right? Which one will be easy to prove? Even that question is hard anyway. The right hand side, we have got 2 cosec x minus sine of x divided by 1 plus cosine of x. I think we can work with this part. This is 2 cosec is 1 over sin, meaning that it is 2 over sin of x minus sin of x divided by 1 plus cos of x. And this will give us, multiply the 2 with what is down here, so that is going to be 2 plus 2 cos of x, multiply the sin with the sin there, so that is going to be minus sin squared x, multiply the two denominators, that is going to be sin x, 1 plus cos x. How do we simplify this one? Where there is sin squared, let me try to replace. So this will be 2 plus 2 cos x, and then minus, where there is sin squared, I'll replace with 1 minus cos squared. So there's already a negative here, and then I replace 1 minus cos squared x. And if I do that, it means what is going to result is going to be a negative 1 plus cos squared x. And then in the denominator, there is a sin x, 1 plus cos x. 2 minus 1 is going to be a negative 1. Alright, this is starting with cos squared x, and then plus 2 cos x, and then plus not a negative 1 but a positive 1 over sine of x, 1 plus cosine of x. The product here is 1, the sum is 2. Are there two numbers we can multiply to get 1? If we add, we get a 2. Yes, there is 1 and 1. 1 times 1 is a 1. 1 plus 1 is a 1. So this is actually quadratic. That thing you can see there is a quadratic on top. So the factors that we want is positive 1 and positive 1. Okay. So because there is a 1 in front of this expansion or this expression, so meaning that if we expand there, we're going to have cosine of x plus 1, and then again cosine of x plus 1. Down, we have got sine of x, then 1 plus cosine of x. So one of these will cancel. We are going to remain with cosine of x plus 1 divided by sine of x. So the left hand side is equal to the right hand side. The function f of x is defined by f of x being equal to x squared minus 3. Want to find the inverse and sketch this graph. The first thing first, when you have got a function that is raised to a power, that is a many to one function. A many to one function does not have an inverse. The only way you can find this inverse is if you restrict the domain. So if you look at x squared minus 3, you can easily sketch this graph. This is x, this is y. So that negative 3 means that the function has been moved all the way up to negative 3 here. Then you can sketch it. It's like that, it goes up. Restricting the domain, you always cut this function on the middle. So cut it on the middle, on the middle. You only take the positive part. So already, to find the inverse, we have said restricted domain is going to be from 0 all the way up to infinity. This domain that we have restricted is actually going to be the range of the inverse function. So now we write the function y is equal to x squared minus 3. Take 3 the other side, that gives you x squared is equal to y plus 3. Square root both sides, x is going to be positive or negative square root of y plus 3. Now, because we have restricted the domain of the function should be equal to the range of the inverse. If you look at this function, for square root, y is equal to square root of x plus 3. If you want to sketch this graph, x is positive, the base is also positive. It is a function which goes like this. If you want to sketch for negative square root of x plus 3, because x is positive, it should still be going to the positive x, but y is negative, the function will be going down. The range of this one is from 0 to infinity. The range of this one is from negative infinity to 0. So this will not apply because we restricted the domain. The domain is from 0 to infinity. The function which has got the range 0 to infinity will be the inverse. So it's the one on top. Therefore, f inverse of x will just pick the positive part, which is square root of x plus 3. So this is going to be it. Okay, very important. And also sketch its graph. We have already sketched its graph is this one which you can see here. Now I want to solve the equation f of x is equal to f inverse of x. And f of x is x squared minus 3. F inverse of x is the square root of x plus 3. What am I supposed to do here? Okay, so we are going to square both sides of the equation. Square this side, square this side. Please never be tempted that no, get x squared to square it alone, you get negative 3 square it alone. Never be tempted to do that. And then distribute the square. If you are distributing, get the x squared to square it, that will give you x to the power 4. Get the power 2, multiply with everything inside the bracket, that will give you negative 6 x squared. Then get the negative 3, square it, that will give you a positive 9. If you want, write it twice and then you start expanding. If you do also this side, you just get x plus 3. So it's quite complex. Let's see if we can use the graph to be able to sketch. I mean to be able to solve it. As a sketch of the graph, you already saw that at negative 3, the function was going like that, and also like this, and then the inverse was going like this. So the intersection point is just this one point. Okay, so it says x to the power 4 minus 6x to the power 2 minus x. If 3 goes this side, it will be 9 plus 3, which is what? That is a positive 6 is equal to 0. So it's the equation that we want to solve. Wow. I'll get this first 2. I'll get these 2 and factorize them. For the first 2, I'll factorize out x squared. We are going to have x squared minus 6 remaining. For these 2, I'll factorize out a negative 1. We are going to have x minus 6 remaining, being equal to 0. So this will give us, marry what is outside, that will be x squared minus 1. Then x squared minus 6 is equal to 0. So this means that x squared minus 1 is equal to 0, or x squared minus 6 is equal to 0. Take the terms the other side, so x squared is equal to 1, or x squared is equal to 6. So this means that x is actually equal to 1, or x is equal to negative 1. And then if you square root both sides for this one, you're going to find that x is equal to square root of 6, or x is equal to negative square root of 6. So these are the possible solutions, but not all the answers are actually solutions. To test, you need to test which ones are answers. You need to go in the actual function. Those which work are the function. I already drew the graph. So from the graph, you can tell at least what should be the value. So the only possible answer is either positive 1 or positive square root of 6. So go in the function and check where there is x, we are going to substitute these solutions. So I'm removing this. Okay, like that. So where there's x, if I put 1, it will be 1 squared minus 3. That is going to be what? That is going to be x. For the left hand side, we're going to find that x is equal to 1 squared. minus 3 is a negative 2. Get the same one you put in the brackets. We are going to find the 4. Square root of 4 is a positive 2. So these two are not the same. So meaning that 1 is not an answer. Get negative 1, you put where there is x. Negative 1 squared minus 1 is going to be negative 2. Negative 1, if you put in the brackets, negative 1 plus 2 is a 2. Square root of 2 is not the same as negative 2. This is not an answer. Get square root of 6. Square root of 6 squared is 6. 6 minus 3 is a 3. Get square root of 6, you put where there is x. Square root of 6 plus 3. So that will be square root of 6 plus 3, and then the answer you square root. Is this going to give us, let me try to punch this, square root of 6 plus 3, and then the answer we square root. That will not give us a 3, so that refuses. Try to put negative square root of 6. Negative square root of 6 squared would be 6. 6 minus 3 is a 3. And that should be equal to square root of, where there is x again, put a negative square root of 6. So negative square root of 6 plus 3. The answer you square root. That will be 0 point something. So none of this is proving. So meaning that there is actually no solution. That's the meaning. And the meaning of that basically is that they don't intersect. But they do intersect for this one. So I'm suspecting, please check through it to see if I missed any number. Otherwise, if this is true, all of them we have proved they are failed, meaning that the solution set is going to be an empty set. You can write it like that, or you can write this. If you write this and end there, don't expect to get all the answers, alright? Make sure that you check, you only get the solutions. In this case like this has failed, it means that there is no answer out of these all. So for x in the logarithmic equation, log x to the power 8 is equal to log x, and then you have got to the power 4. You want to solve for x. This 8 that you can see in front, I can take it down, which is as a power, I can take it down. So it becomes 8 log of x is equal to log of x to the power 4. I'll say let b be equal to log of x. So this becomes 8 where there's log of x, we'll put b is equal to, where there's log of x, we'll put b, but that is raised to the power 4. I'll take the terms to the same side, so that becomes b to the power 4 minus 8b is equal to 0. Factorize out b, so that will be b minus, and this will be b cubed minus 8 is equal to 0, meaning that b is equal to 0, or b to the power 3 minus 8 is equal to 0. If you take 8 to the other side, becomes b is equal to positive 8. And then cube root both sides. What number can you multiply 3 times for you to be able to get 8? We know that is a 2, meaning that b is equal to 2. So there are two possible answers of b. Our aim is not to find b, but to find x. So get back here. But log of x is equal to b. So log of x is equal to 0. What does that mean? Let's say log of x is equal to 0 means if you can express that as an exponential. So ever the base here, let's say the base is 2. 2 to the power 0 is equal to x. Okay, that's the meaning. Okay, let me write that. Log of x is equal to 0. The base here is 10. For any log, the base is 10, meaning that 10 to the power 0 is equal to x, meaning that x is equal to 1. Any number is to the power 0, the answer is 1. That is one solution. And then for the other one, when x is equal to 2, so we're going to, when b is equal to 2, log of x is equal to 2, meaning that 10 to the power 2 is equal to x, meaning that your x is equal to 100. So these are the two possible values of x. For b, find the domain of f of g of x, where you've been given f like that and also g. Okay, so f of g of x, we are getting g, we are putting in f. So g is square root of x plus 4. So that will be 1 over, where there is x, we are putting square root of x plus 4. Then minus 2. When you are finding the domain of a rational function, the denominator can't be equal to 0. Very, very important. Okay, square root of x plus 4 minus 2 cannot be equal to 0. Take to the other side, square root of x plus 4 cannot be equal to 2. Square both sides, meaning that x plus 4 cannot be equal to 4. Take for the other side, meaning that x cannot be equal to, if you take it to the other side, x cannot be equal to what? 4 minus 4, 0. So x can't be equal to 0. But even if it's like that, also what is in the root, x plus 4, can never be negative, meaning that x plus 4 can never be less than or equal to 0. Okay, it can never be less than or equal to 0. It can be anything that is positive but not a negative number. What does that mean? That means that x can never be less than or equal to, take for the other side, negative 4. If you put this on a number line, if negative 4 is here, you are saying that x should always be bigger than negative 4. But remember, you said that x cannot be 0. So 0 is an exception. I'll put an open dot there. So meaning that our domain for this function is from negative 4 to 0, and then from 0 to infinity. Okay, so this is our domain. We are including negative 4 because if you have got square root of negative 4 plus 4 is 0, 0 minus 2 is 2, negative 2, and the denominator is still defined, it's not equal to 0. So if you don't put closed here, you get it wrong. Sketch the graph of the following rational functions indicating all their asymptotes. First thing first, for find the asymptotes, horizontal asymptote is given in terms of x value. The denominator can't be equal to 0. 1 minus x shouldn't be equal to 0, meaning that x cannot be equal to what? 1. Okay, that is an horizontal asymptote. Vertical asymptote. Oh, this is actually the this is actually the vertical asymptote. The vertical asymptote is given in terms of x. You are talking about values from, you are talking about a line that will cut the x-axis. That is vertical. Now horizontal asymptote is given in terms of y. You are basically finding the limit as x approaches infinite for this function. In a case where the highest power on top and the highest power down are the same, just get the numbers in front to divide them. So the number in front of x on top and down, negative 2 over negative 1. So meaning that y is equal to 2 is the horizontal asymptote. At this point now, equate everything to 0. Equate what is on top to 0. 6 minus 2x is equal to 0. X is going to give you 3. Equate what is down to 0. 1 minus x is equal to 0. X will give you 1. And then get these two values. You have found 1 and 3. Write the factors 6 minus 2x. When I equated 6 minus 2x to 0, I found 3. If I get any value of x greater than 3, for example, a 4, I put where there is x, I'll get a negative. Try 6 minus 2 times 4, that is 8, is negative. Immediately I close the 3 for that factor, it will be positive. Get any number less than 3, put where there is x. And then we also had the 1 minus x. When we equated 1 minus x to 0, we found 1. Anything above 1 will give me negative. For example, try 2. 1 minus 2 is negative. Anything below 1 will be positive. These two factors, remember, they were dividing, we're interested in the quotient. Positive over positive is positive, negative over positive is negative, positive over negative is positive. Now we can sketch our graph. The critical values of this graph we have got. So some important points we need to put, we have got x is equal to 1 and x is equal to 3. The asymptote is at x is equal to 1, so I'm going to put dotted lines here. And then the horizontal asymptote is at positive 2. So I'll put also dotted lines there. When the function is less than 1, the function is positive, meaning that it is below the, it's above the x-axis, and mostly above the x-axis and above the two asymptotes. So be following the asymptote like that. You can't cross the asymptotes. Between 1 and 3, the function is negative. Between 1 and 3, the function is supposed to be negative, meaning that below the x-axis. So I'm following the asymptote and going like that. And then above 3, the function is positive. So meaning that you are crossing the x-axis and then going like that. But you can't cross the asymptote, so just continue going like that. So this is a sketch of the function, okay, indicating all asymptotes and intercepts. The only intercept here is 3 and this number here. This number, for you to cut the y-axis, it happens when x is 0. So where there is x, put 0. Put 0 here, put 0 here. That will be 6/1, meaning that this is at 6. And the very last question, I believe here, find the limit as x approaches infinity of 2x plus 5 divided by x squared minus 7x plus 3. You are finding a limit of a function like this one. Try to see if you can factorize out the function. But even if you did factorize, this function is going towards infinity, so that will barely help. What you want to do is divide all the terms by the highest power. Okay? Divide all the terms by the highest power you can see. So the highest power is 2. So this will be limit as x approaches infinity. Divide everything by x power 2. By x power 2. So 2x divided by x power 2, that will be 2 over x, because 2x over x power 2. 1x will cancel with 1x. 5 divided by x power 2, that will be 5 over x power 2. In the denominator, x squared divided by x power 2, that will be 2. 7x divided by x power 2, that will be 7 over x. 3 divided by x power 2, that will be 3 over x power 2. Where there is x, now substitute with infinity. So that will be 2 over infinity plus 5 over infinity squared over 2 minus 7 over infinity plus 3 over infinity squared. A number over infinity is 0. So I've got 0 plus 0 over 2 minus 0 plus 0. This is 0 over 2, which is a 0. So this is going to be 0 as the limit. Determine whether or not the function given here is continuous. There are 3 things that you do when you want to determine that a function is continuous at a given point. The first thing is at that same given point, find out if the function f of that number is defined. Okay, so the first thing is we want to find out at if it's continuous at x is equal to 4. So find out f of 4. So going into this function, which one is including 4? It is the downward one. We can say x is equal to 4. So x is equal to 4 is 0. And this one is defined. That is the first thing that you want to meet. So the first one has been met. And then the second one, we want to find out if the limit does exist. Okay. So the limit as x approaches 4 from the negative for this function. So when you're approaching x is equal to 4, what number are you approaching? As you approach x is equal to 4, you can see for this one, x cannot be equal to 4. For this other one, x is immediately 4. Try to sketch. Okay, you can do this. When you get 4, you put in the function on top. You're going to have 4 minus 4, which is a 0. And then 4 minus 4 down also is a 0. But remember, x cannot be equal to 4. So 4 itself cannot be the answer. But as you approach 4, what answer are you getting? Try to get a number that is very much near to 4, but not 4. And it should be like from the negative side. From the negative side. In other words, a number near 4 but smaller than 4. Let's get 3.999999. Let's put where there is a 3, where there is x with that number. So we'll say 3.99999. I'll use 4 nines, 5 nines. I'll subtract a 4, and then I find the absolute value of that number. So absolute value means it should always be positive. And then I'll divide by itself. So the answer is giving me a 1. Okay, the answer is giving me a 1. Actually, not a positive 1, but a negative 1, because in the denominator we're going to have a negative number. 3.9999 minus 4 to be negative 0.000. It should be like a 1 at the end. So this one limit is giving me a negative 1. Okay. And then I also need to find the limit as x approaches 4 now from the positive side of this same function. Get a number near 4, but it shouldn't be 4. It should be slightly above 4. Let's get 4.0001. So 4.0001 minus 4 will be like 0.0001. And then down 4.0001 minus 4 will be like 0.0001. If you divide those two numbers, are going to get a positive 1. These two limits, are they the same? They are not. So meaning that limit as x approaches 4 for the function f of x does not exist, because the limit from the negative and from the positive are not the same. So your aim was, if this was existing, the limit as x approaches 4 should be the same as f of 4. But since 0 is not the same as does not exist, now make a conclusion. Since f of 4 is not equal to the limit as x approaches 4 for f of x, then the limit is not continuous at x is equal to 4.